We are students of Marmara University, Faculty of Engineering, Department of Computer Engineering. Our project is scanning railroads with ARKit and application of Pathfinder. My project partner is Musa and Özey and Furkan Akan. I'm Mevlana Ayas. We worked on indoor navigation to solve navigation problem that is not covered by current applications. There exist some popular solutions, but they are focused on users' position to use it on advertising. Our main reason to choose this topic is to help people. For example, we can help visually impaired people with voice commands, or we can show a path to important points in mall, hospital, or museum. We try to use an ARKit to solve navigation problem. We can track user position, scan environments, create AR objects, and combine these features to use in navigation. Simple use case of application: user places the QR code. QR is origin of our virtual world, and after application reads QR code, scanning starts. After all points scanned and all labels placed relative to our start point, user sends data to server. After data saved, each user can access map with placed QR. QR gives us ID. An application retrieves data from server. We are going to have grid-based map data and label points and be ready to use for pathfinding.
For scanning phase, we are using ARKit. ARKit is an augmented reality library that is developed by Apple. We are using this library as our data source for point cloud and movement changes of device. This is an example point cloud data that is given by ARKit. As you can see from this image, point cloud data can be really big and detailed. So before using it in our application, we need to simplify it. To process it, we divide the word to chunks. Each chunk covers 1.6 meter cube. Each chunk contains a 3D map in it. When ARKit gives us a new point, we find its chunk and block of it, and increase density of this block 1 unit. We use this density to eliminate point cloud errors. After these steps, this is how our point cloud data looks like. After completing scanning, user sends this data to our server. Our server optimizes this data in some aspects. First one is converting 3D map to 2D map. We only support pathfinding in one plane in our application, so we don't need 3D map. After that step, server projects user movements to map and sets density of this movement path to maximum. Because if user can walk on this path, this means that it's most reliable path for us. After these steps, server compresses and saves this map to our database.
We use image recognition feature of ARKit. It provides recognizing picture which is known by ARKit and provides location of picture in virtual space. Thanks to this, users initialize their position and download maps by scanning QR codes, which contain specific picture on background. They can select destination if they scan QR code successfully. After selection of destination, the shortest and the most reliable path to the destination shown as augmented reality. We use A-star algorithm to find this path. Shortly, A-star algorithm finds grids that has minimum cost until reach the destination. Cost is affected by directional cost, reliability, and heuristic. Directional cost 1 for up, down, right, and left directions, and 1.4 for cross directions. Reliability is calculated when create map. Heuristic, Euclidean distance of next movement to the destination. Also, we find Gx, which is directional cost plus 1 minus reliability plus Gx. Gx on the right side is Gx of previous grid, where we used to reach current grid. Sum of Gx and Hx give us cost of next movement cost. A-star algorithm is searching grid based, so result consists of grids that user should go step by step. It makes path look broken. Therefore, we use line of sight algorithm, which selects most distant grids that see each other. Thanks to this, path becomes smoother. Finally, the path is shown as augmented reality.
Application reads QR by using ARKit image recognition and detect known image in the environment and use this information to place AR content. In this case, they are our map points and labels. Now we can see labels. These are placed relatively to our QR code. We can select destination point and pathfinding algorithm will be triggered. The result of pathfinding is going to be shown on screen as AR object. Application detects user movement and position, and new calculations will be done with updated locations of user. Thanks for watching.